Yes, our flag. Yes, I'm going to discuss now flag. What is the flag? What is the address? Okay. Yes, I'm going to discuss the flag field. Okay, the flag field, it is going to contain the 8 bit of numbers. Okay, that 8 bit sequence with the form of patterns. Okay, here I have taken 0 1 1 1 1 1 0. Okay, this is what I have taken the sequence. Okay, this sequence, it is going to identify the beginning and end of the frames, as well as it is going to serve as a synchronization pattern for the receiver side. Okay, this is what our flag field information. And next one is address field. Okay, the address field, it contains the address of the secondary station, and if the primary if the primary address, it is going to created the frames. Okay, that frame, it going to contains the to address. Okay, it is not contain the from address, it is going to contain the to address, means it is going to contain the destination address. Okay, and if the secondary address or secondary field, it is going to create it the frames. Okay, that secondary frames, it is going to contains the from address, means it is going to like stores the source address, and it can be one byte or several byte of address. That is going to depends on the network, means it is going to contain the one or more byte of address. That is all the address, it is going to depends on the one of the network. Okay, because why? Because network means with the help of network only we are going to access the particular source and destination address. If the address field is only one byte, the last bit is always is a 1. Okay, if the address is more than 1 byte, all the byte but the last one will end with the 0, only the last will end with the 1. Means if the address field is only one byte, the last bit, it is always be first. Means see, this is the last bit will be 1. Okay, if the address field is more than 1 byte, okay, I mean the sequence of pattern is more than 1 byte, all the byte but the last one will end with the 0. See, if starting and like beginning and ending byte will be end with the 1. Okay, in bit will be 1 1 1. So this is what this. The next one is control field. The control field, it is going to tells the control the information or control the data within that frames. Here 1 or 2 byte segments of the frames used for flow and error control, means here all the frames, it is going to send the one like sequence order, as well as without any error. Okay, the next one is information field. Okay, the information field, it contains all the users data from the network, and also it is going to manage that particular information. Okay, then what is FCS? FCS is nothing but frame check sequences. Okay, so this is what our FCS. Okay, this all will like contain from here. I'll show what is that. See, this is what our HDLC frame. See, flag, address, control, user information, FCS flag. Okay, this like this all those things means flag, address, control, control field, FCS field. See, everything is same for all the frames, means iframes, S frames, U frame, means iframe is nothing but iframe is nothing but information frame, S frame is supervisor frame, and unnumbered frame. Okay, here all these fields are same. Hmm. So next is FCS, means frame check sequence. Here frame check sequence, it can be used for error detection, and it is also contain the 2 or more byte of information, and also it can contain the cyclic redundancy code, means all the error free method. Then this control field, it is going to determines the type of frames, and it defines its functionality. Okay, see, this is what how the control field, it is going to uh, tells their functionality. Means it is going to made up of a sequence of bit. Okay, that sequence it contains the sum of bit patterns. Okay, here 0, like these all are no numbers, means and these all are the numbers means there is no center side numbers, and this will be receiver side number. Okay, this is what framing will be looks like. Then what is the control field for iframe? See here, this is what our iframe. So this is what our iframe. Now I am going to we will discuss about what is iframe will stands. The control field for iframe, the bit 1 defines the type. If it is 0, then 1. Okay, if bit 2 and 4, okay, see if it is bit 1, it defines the type 0 and I. Okay, so if it is bit 0 bit 1, it is going to defines the bit 0 and I. Okay, if it is bit 2 and 4, this is bit 2 and 4. Okay, it is called ns, define the sequence number of the frame. Okay, sequence number of the frame. If it is bit 5, dual purpose bit p, means polo final 1. See bit 5, it is the dual purpose, it is the dual purpose bit. So this is what the bit 5. Okay, this will be dual purpose bit p polo of 0. That polo frame sent by the primary and finally frame sent by the secondary. Okay, the polo frame initially it is going to send by that particular bit into primary device, and finally it is going to send by the secondary device. Here primary and secondary it is works as a sender and receiver. So bit 6 and 8 we called as the number of the receiver side. Okay, that will be number of means sequence of the sender side, and this will be sequence of the receiver side. Okay, that correspondence or the correspond of the bit, it is going to sends the send the information through the acknowledgement format. Then what is the control field or in the S frame? The control field for S frame are used for flow and error control. Okay, this flow and error control, the frames does not have any information field. If the first two bits of the control field is 10, means 10, this means the frame is in the S frame. Okay, see, if the starting two bits it contains the 10, so we can easily call it as a S frame. Okay, then if the starting bit if it is 0, okay, that bit we call it as a I frame. If it is 1 that we call it as a U frame. See, if it is the starting bit it contains the 2 bit contains the field is 10 value, so this means we consider as the S frame. Okay, the last 3 bit we called as a NR, the correspond to the acknowledgement. Okay, that we call it as a NAC. Okay, NAC means here not a ACK, that we call it a number of acknowledgement it is going to send. That the so this is what the abbreviation of NAC. Okay, the second bit called code is used to define the types of S frame itself only. Then what is the receiver ready? That we call it as RR code. Okay, then receiver not ready. Okay, so it is going to works our S frame, it is going to works about the two functions, not two functions, more than that function. Okay, that is one is receiver ready and receiver is not ready. Okay, in receiver ready what will happen? Okay, either the code or the field, the subfield, it is going to contain the 00 value. Okay, then you can consider that it is the RRS frame, means the receiver ready at the S frame. The starting the starting two fields it contains some of the value of 00, then it is called our bit will be ready in the S frame. Okay, then after that is going to send the acknowledgement to particular destination. Okay, in the form of groups. Okay, once the receiver it is going to receive the particular frames. Okay, and it is going to send the number of acknowledgement back to the receiver. Then receiver is not ready. Okay, the receiver is not ready. It is going to tells the subfields is 10, then it is and consider as a our receiver is not ready. Okay,